Good morning, guys. This is material that you may have missed from the last couple days after Thanksgiving break. So before the break, you took those notes on heredity, inherited and acquired traits, and then on genes with the substitute before Thanksgiving. If you haven't done that yet, if you're missing any of that information from the last few days before Thanksgiving break, then you need to make sure you've done that before you watch this. Go back, watch those, and make sure that you have all the material that you need. Well, one of the things that I discussed when there was a substitute on the video that I made was genes. Now, your inherited traits, those are the traits that are determined by your DNA. Each inherited trait is associated with one gene. So if you have your DNA strand, it looks something like this, and it's very long, right? Coiled up in those little bundles called chromosomes, and there's 46 of those chromosomes in each of your cells. That's your DNA that makes you who you are. So a gene is just one little piece of that DNA strand. That's a gene. And each gene, like I said, is for an inherited trait. So maybe this is for hair color. Then the next little piece would be for whether your hair is curly or straight, maybe how tall you are, etc. And you line them all up, all those thousands and thousands of traits that make you who you are, and that is your DNA strand. Well, one thing you should have written down in your notes is that you can write a gene using a two-letter combination, something like this. Maybe I should make it a little bigger here. A two-letter combination. Okay? Now, each of those letters represents a part of a gene called an allele. Okay, that's a part of a gene. It's one of the two pieces that can be passed on to the child. Whenever you have a child, mom and dad each will pass one of those alleles, one piece of a gene, to their child. So you get one allele from mom, one allele from dad, and the child then has a gene that is made up of those two alleles. Now it's random which one is given. So one thing we learned this week in class was how to write a gene. So let's just use something like hair color. Let's say that there's a brown hair and red hair. Now, we talked last week about dominant and recessive, maybe very briefly. Dominant traits are the traits that are strong. They are more likely to show up. Recessive traits are weak. They are hidden often and don't show up. For example, maybe you have brown hair, but you could potentially pass on blonde hair to your child because you have a recessive trait for that that's not being shown, but that you could pass on. It's weaker. So let's say that in this family that brown hair is dominant. It's stronger. Most of the kids in the family have brown hair. And every once in a while they get a red-headed child. So we'll say this is the dominant trait. Well, the first thing we need to do when we write a gene is to choose which letter we're going to use. The rule is you take the first letter of the dominant trait, and that's the letter you use for your gene. Well, what's the first letter of our dominant trait? Well, this is dominant. The first letter is B. So we're going to use the letter B for our gene. Now, that means that brown hair, the dominant trait, will be represented by a capital B. And red hair, the recessive trait, will be represented by what? What do you think? If you said lowercase r, you're wrong. We actually use the same letter. We still use a B, but we do use a lowercase b. Now, there's a few possible combinations that you could get from this in the gene, what we call the genotypes. And again, you should have written this in your notes already from last week, although we didn't talk about it. Genotypes are just the possible combinations. You could have two capitals. What else could you have? Think about it for a second. You could have a capital and a capital, so two dominant alleles. You could also have this, right? Two recessive alleles. What else could you have? You could have a dominant recessive. And you could also, of course, have a recessive dominant, but we don't usually write that one because isn't this the same thing as this, one of each? But we always put the dominant first. So we're going to get rid of that one. All right. Now the next question is, what will these look like? What will the phenotype be? Again, you wrote a definition of this in your notes already, so maybe take a look at it. Phenotype is just how this gene is expressed. In other words, which of these traits do they get because of that gene? Well, obviously this would be what? Big B, big B. If somebody has this gene, they're going to have brown hair. That's their phenotype. Right? And what about this one? If somebody has lowercase, lowercase, or two recessive alleles, they will have what? Yeah, they'll have red hair because they got the recessive trait. But what if they have one of each? You might think they would have reddish brown hair. That would make sense. But no, because in this case, this is stronger. It's dominant, and this is weaker. So it gets hidden. The dominant sort of steps out in front, and it hides away the other one. This person would also have brown hair. That would be their phenotype because the dominant overrides the recessive. It's hidden, and this is all you see. Now, can you get mixtures? Yes, but that's a different process. So we'll just keep it with dominant recessive for now. So this one is dominant, and so you still have brown hair. All right? That's how you write a gene. Let's do one more. Let's talk about our ears, which we talked about last week. Remember, Mr. Dahl has these nice attached ears, and that's rare. That's recessive. I'm very proud of that because I like my little attached ears. They're very sleek and aerodynamic. They help me when I swim to go faster because they don't catch as much water. Probably not that much of a difference. But let's say that some people have the dangling ears, which is more common, and some people have attached ears, which is more rare. Okay? Well, which one of those is dominant? The dangling ears, when you have an earlobe that hangs down like most people do. So that's dominant. So what letter do I choose for my gene? What was the rule again? The first letter of the dominant trait, which is what? The letter D. So I'm going to use a capital D here. And what am I going to use for attached ears? Lowercase d. All right. So my genotypes are this, this, or this. And my phenotypes would be dangling, which I'll just say dang, attached, and what's this one again? The dominant overrides the recessive, and so once again you get dangling ears. The only way you get the recessive trait is if you happen to have two recessive alleles, otherwise you're going to have the dominant trait. That's why it's so rare to get this. Because there's multiple ways of how you can get the dominant. Okay? So that's how you write a gene. Now, the thing that I'll talk about later on, we talked about this in class on yesterday, on Tuesday, Tuesday and Wednesday, I guess, is that now we can predict what parents will pass to their kids. So let's say that mom has dangling ears. The dominant overrides the recessive. She has dangling ears. And dad has what kind of ears? Attached, like me. Well, when they have a child, remember that mom and dad each give one of those two alleles. And this is true for every single trait, for their hair color, for their height, for their attached ears or whatever. Every single gene in that DNA strand will give one of the two alleles, and it's totally random which one they give. So let's just say that when they have a kid, maybe mom randomly gives this one, and dad randomly gives that one. The child would have dominant recessive. They would have dangling ears. If mom gives that first one and dad gives the second one, well, it's the same thing, right? Dangling ears. But if mom gives the second one and dad gives this one, then you get attached ears. And here, same thing, attached ears. You can see there's a 50-50 chance of getting attached or dangling. That makes sense. Mom has dangling, dad has attached. Okay, 50-50. Who gets it passed on, right? That makes perfect sense. But what about this? It doesn't always have to be 50-50. What if mom and dad both have what kind of ears? They both have dangly ears, so neither of them have this. They both have the dangle. Mom gives this. Dad gives this. You get dangling ears. Mom gives this. Dad gives that. What kind of ears is that? Capital lowercase. That is also dangling ears. Mom gives the second one. Dad gives his first one. Wait a minute. Again, that's dangling ears. And then here we finally have attached ears, right? In this case, what's the probability of getting the attached ears? It's only 25%. And what's interesting about that is, remember that mom and dad, neither of them had attached ears. They both had dangling ears. But they do have a 25% chance of having a kid with the attached, even though neither of them have the trait, because they are carrying the allele for it and they could pass it on. Now, last thing for today. I think, well, let me tell you what I have. Obviously, I have these attached ears. So we know what my gene is. What do you think my gene is since I have attached ears? What is it? The only way you get the recessive trait is two recessives, right? Well, my wife has dangling ears. Carlene has dangling ears, so I think she's either this or this. In fact, I know she's one of those two. The question is, which one is she? I'm pretty sure she's that one. Now, watch this. If she gives that, I give this, our kids would have dangling ears. She gives this, I give that, our kids would have dangling ears. If she gives a second one and I give the first one, dangling ears. And if she gives the second one, I give the second one, dangling ears. What is the chance of us having a child with attached ears? 0%. There's no chance if that is her gene. Even though I have those ears, I can't pass them on to my kids, and that makes me sad because I love my attached ears. I wish my kids could have them. I'm pretty sure that that's her gene because I have 4 kids. So far, all of my kids have dangling ears. Now, it's possible if we had a 5th kid, which we probably won't, that maybe then the attached ears would come out and then say, oh, well, okay, that means we have this. But I don't think that's the case. I think that her dangling ears are double dominant. And that makes me sad because then I can't have kids with my attached ears. However, there is one light at the end of this tunnel, which is that if my child marries somebody, they could give the little d, and my grandchildren could get my attached ears. And where did they get it from? From mom or dad, who got it from me. And so there is hope that maybe my grandkids could have my attached ears. We'll do more with this tomorrow, another time. We'll have some practice with it. I'll have an activity for you tomorrow. Thank you for watching this, and hopefully I'll see you in class soon.